Good morning, good morning. Jesse, that was just for you. This is hopefully part two. We might have even gone this far. If you have already taken notes on example 6, why don't you just fast forward a little bit? I just had absolutely no idea how far you'd get, so I'm going to go right here. This is chapter 2, section 2, calculus. And we're using our derivative rules, differentiation rules, in order to do things. And this one just says use parentheses to help you differentiate. So meaning we want to look for things we can, I hate the word chunk, but we are looking for things we can chunk and group together. And so on this very first one, y equals 5 over 2 x to the third, I would write that as y equals, and then I would think of that as 5 over 2 times 1 over x to the third. So there's my parentheses to do that. And so then at this point, I would move it and I'd make this 5 equals 5 over 2 times x to the negative 3 power, because I don't like the negative exponents. Now I can differentiate that. I can take the derivative of it. So I would now have y prime equals, I bump the power to the front, so that becomes negative 15 halves. So the negative 3 times the 5 is negative 15 halves. And then x to the negative 3 minus 1 goes to negative 4. If I want to write that more accurately, I could write that as, actually I don't want that equal sign there. I would write it as the derivative is equal to negative 15 over 2x to the fourth, because I can move the x to the fourth back down. All right, moving on to this one now. We're supposed to use our parentheses to help us differentiate. Well, I can't do anything unless I get rid of that power of 3. So this is going to turn into y equals 5 over 2 to the third power is 8 x to the third. Now that I've done all that, I can go to y equals 5/8 times 1 over x to the third, and that's going to be y equals 5/8 times x to the negative 3. Again, bring my exponent to the front, so that is going to go to y prime equals negative 15/8 x to the negative fourth, and then for my final result, the derivative is equal to negative 15 over 8x to the fourth. The further we get, the more likely we're going to be to just leave our negative exponents in our final answer. But if we can avoid it at all, we like to do that. So coming on down here, this one, I'm going to go back to blue. I'd write as y equals 7/3 times 1 over x to the negative 2. So that would be y equals 7/3 times x squared. So there the negative was on the bottom. When I move it up, it goes positive. So my derivative is simply 14/3 and then x. Done. I don't even need to rewrite that one because it's good enough right where it is. Then bottom one here, I'm going to move that whole thing up before I even begin. So this is going to be y equals 7 times 3x squared, and then that'll be 7 times 9x squared, or y equals, that will be, sorry, I just hit the microphone there if you heard that, 63x squared. And so derivative, 63 times 2 is 126x. And there I would have my derivative for that one. All right, moving on to the next page. And I'm going to hope that we actually did do this before, but if not, we're okay here. Sum and difference rules. To differentiate these, we want to take each one individually. So we can take the derivative there, then we take the derivative there, and then we take the derivative at that point. So my derivative of the f function, move the 3 to the front, I get 3x squared, because 3 minus 1 is 2, minus 4, and then 1 minus 1 is 0, so that's just a constant. And then derivative of a constant is 0, so I am done at that point. That would just be 3x squared minus 4. This one, it's hard to write a g. All right, g of x, derivative there. Okay, I would move my 4 to the front, so I'd have negative 4 over 2 x to the third, because I'm thinking of that as a negative 1/2 in front, is what in my mind I'm thinking of. And then plus 9x squared minus 2. And then I'll simplify this one. So my derivative is negative 2x to the third plus 9x squared minus 2. And there's the whole derivative for that page. Remember, you guys, if I'm going really fast, slow it down and copy whatever you need to. New rules, example 8, if you didn't get these, hopefully this is a good place to start. Sine and cosine, these are just things to memorize. Derivative of sine is cosine. Derivative of cosine is opposite of sine. My hint, if I am taking the derivative of any of those trig functions that started with a c, they all end up with the minus sign in front of it. I don't know how long it took me to get that little thing in my brain. And so any of the trig functions that don't start with a c, they remain positive. But any of the trig functions with a c are going to go negative when we do it. So when I come down to get the derivative of y equals 2 sine of x, okay, derivative of sine is cosine, and this is just like a constant sitting in the front. So this is y equals 2 times the cosine of x, because 2 is just a constant sitting in front, so that does not impact anything. This one, I'm going to pause. I was trying to figure out what this actually said. This reads as y equals the sine of x over 2. Makes it a little easier to see if you're looking at that. And again, just like we talked about on the earlier one, it helps if you can pull things out. So this would be y equals 1/2 times the sine of x, because that 2 on the bottom, that's just a constant in the front. So constant stays put. Derivative of sine is cosine. So my derivative there, oh, look at my poor notation. I did not put the derivative notation up there on A. You guys all probably caught that, and I did not. The derivative of this one would be y prime equals 1/2 cosine of x. All right, then part C down here, scrolling down to get to it. Now this is more of a polynomial type of function. We've got one here, one here. The stop sign separates them. So when I go to take the derivative of x is just 1, because the coefficient in front, bring the power down, 1 times 1 is 1, and then x to the 0 is just plain 1. And derivative of cosine is opposite of sine. And that finishes that one out. All right, that would be the end of day 1. So just in case we didn't finish everything that first day, I wanted to save this one. So this is going to be part 1.